Recall, if you can trace a graph of a function f continuously from one side of C to the other, then the limit of the function when x approaches C equals f of C. As example of such function, we have, for example, the polynomials. And that's why the limit when x approaches 4 of x to the power of 2 minus 3x plus 1 is just f of 4, which is 4 to the power of 2 minus 3 times 4 plus 1, which equals 5. The exceptions are piecewise functions made from traceable functions. In this case, you must check all values of the x's between the pieces. We call those suspicious points of the piecewise function. Example: in this case, we had to check the limit at x equals 2 by taking the right limit, the left limit, and to check if the limits are equal. We call that 1, 2, 3. Here is an example. The limit of x to the power of 2 minus 25 over x minus 5 when x approaches 3. The first question is to ask if substitution is possible. And the answer is yes. So we do. We substitute x equals 3 and we get 9 minus 25 over negative 2, and after simplifying we get 8. What about this limit? The function is the same, but now the limit is x approaches to 5. In this case, the answer is no. When we substitute 5, we get 0 over 0. Because substitution is not possible, we will try some algebra. In this case, we can use what we call cancellation. We are writing x to the power of 2 minus 25 as the product of the terms x minus 5 and x plus 5. Now it's a cancellation. And we get that this is limit of x approaches 5 of x plus 5. Now we can substitute, and we get 10. Here's another example. When x approaches 4, I'm going to substitute 4 in the denominator, and I get 16 minus 4, which is not 0. It means that the answer is yes. I can substitute. And when I do, I just substituting 4 for the x, and I'm calculating the numbers. And I get 1 over 6. Now, again, it's the same function, but now the limit is when x approaches 2. But now when you do that, you get 0 over 0. So the answer, if can I substitute, is no. So I have to use some algebra mean. We will use cancellation. We will write the top as x minus 2 times x minus 3, and the bottom as x minus 2 times x plus 2. Now I'm cancelling the bad. Why this is the bad? Because this is what is 0 when x equals 2. Now when I get x minus 3 over x plus 2, I can go ahead and substitute x equals to 2. And I get negative 1 over 4. Example. We will start by simplifying this. Common denominator is 3x, and we get that. Now we will simplify more. We want really to get one fraction. We want to avoid, by all costs, any composite fractions or any complicated expressions. And we get that. Now we have to notice that because x minus 3 is the opposite of 3 minus x, 3 minus x over x minus 3 equals negative 1. Now we can go along and just substitute 3 for the x, and we get negative 1 over 9. Computing limits using rationalization. Rationalizing is based on the following fact, that a plus b times a minus b is a to the power of 2 minus b to the power of 2 when a and b are positive. A plus b is also the conjugate of a minus b, and a minus b is the conjugate of a plus b. Example: square root of x minus square root of 3 times the conjugate, which is square root of x plus square root of 3, is the first one to the power of 2 minus the second one to the power of 2, and we get x minus 3. Here is the first limit. Limit 5 minus x over square root of 5 minus square root of x when x approaches 5 is what? Substitution is not allowed, so we will have to use algebra. In this case, we can rationalize. I'm going to multiply top and bottom by the conjugate of square root of 5 minus square root of x. And I get that. Pay attention that I don't multiply everything out. I'm just simplifying the problematic part. The problematic part, in this case, is the denominator of this fraction. Now I can spot the cancellation, 5 minus x. And I get that. Now I'm free just to substitute 5 for the x, and I get square root of 5 plus square root of 5, which is just 2 times square root of 5. Here is another way. We can also use, in this case, cancellation, because we can break down the 5 minus x. We can write the 5 minus x as the square root of 5 minus square root of x times square root of 5 plus square root of x. And now we can cancel that, and we get this. Example: limit of square root of 3 plus x minus square root of 3 over x when x approaches 0. First we try to substitute x equals 0, and we get 0 over 0. In this case, by the way, you cannot break down the x to a product, so the only way to do this one is really by rationalizing. We are going to multiply top and bottom of the fraction by the conjugate of square root of 3 plus x minus square root of 3, which is square root of 3 plus x plus square root of 3. We always like to leave alone the problematic part in the denominator. So we simplify the numerator using that, but we leave the denominator alone as it is, because the problematic part is x, and we really need to cancel that. We simplify more, and now we can see that we can cancel the problem, which is x equals 0, and we get that. Now we can go and substitute x equals 0. We get that. That can be simplified and be written as 1 over 2 times square root of 3. Be careful. You should not multiply the problematic part, the zero term in the denominator, with the non-zero term or terms. You want to leave them as product of terms. The zero term should be cancelled anyway. Example, limit of x over square root of 4 minus 2x minus 2, x approaches 0. We have to rationalize here. We don't have any choice because we cannot break the x to a product. The problem, which is the x part, which is 0 when x equals 0, is isolated, and we want to keep it that way. We get that. We simplify more. Now you realize that you can cancel the problem part, which is the x, and we get this. Now we can go ahead and substitute 0 for the x. We get that. Square root of 4 is 2. So we get negative 2 plus 2 over 2, which is just negative 2.